All right. So I've been doing core data for a long time. I co-wrote a book on core data, and yesterday there was some shade thrown on core data here on this stage, and I appreciate that because there are plenty of haters, and haters are going to hate. But I'm going to see what I can do to try and shed a little bit of light and hopefully dissipate a little bit of the shade. So let's see what happens when you try to put these two together. This is, of course, one of the epic battles of the century, as some of you may have encountered. And I'm going to attempt to make some peace here. And I got a few things to cover. Just some general, why don't they play together well? What Xcode can help you with, what it won't help you with, what it'll fight you with. Some common stumbling points, WTFs, when using Swift with core data, and how to make things better going forward. So this is not an intro. I just thought I'd mention that because some people have never used core data, and I'm going to assume a little bit of knowledge, but if you don't know, you can ask me at office hours. So let's get right into that. But first, a little bit of history on this. I have an abbreviated timeline here. And so core data first came out in 2005. 2009, it came to iOS. It wasn't in the initial SDK. And then a few years later on, Swift shipped. And Swift has been updated since then. And the reason I'm showing you this timeline is because in its heart, core data still thinks you're using Objective-C with it. It really believes that. And this is going to show up, and that's why there's this conflict when you're trying to use it in Swift. So how does that show up? First, in the case of your data model, core data, by the way, is the M in MVC and other design patterns. It intends to be Apple's generalized solution to being a data model in your app. But it can only store model objects. There's you can't use your data model in structures, for example, even if you're using Swift, because core data doesn't understand how to use those. And not just that, but your model objects must inherit from an managed object, which is the core data root object. So you can't use pure Swift classes either. It's got to be an Objective-C class with this specific inheritance chain, because that's what core data wants to do. Where this really becomes a problem is with core data's properties. When you have properties of your model objects, anything that core data is going to store has to be something that Objective-C can represent. And so this means, for example, you can't have pure Swift types like structures or enums as your properties on your model objects, unfortunately. We'll talk about that a little more later on. But even if you go with objects as your properties, though, they have to inherit from NS objects. So again, no pure Swift classes there, unfortunately. Optionals can be tricky. There are some real stumbling blocks there. I'll cover that in more detail in a couple of slides. And you get this nice built-in support for properties that conform to NS coding. So anything you convert to a binary bit of blobs can be a property in core data. But they have not yet warned about Codable in the core data world. So again, NS coding is great if you have something that inherits from NS object, because NS coding kind of requires that. It would be really nice to have Codable. We don't have that yet, unfortunately. And finally, in terms of relationships between your model objects, core data will represent your too-many relationships as an NS set, which is a foundation core data class which can contain anything. It's not typed at all, which is a bit of a pain if you're used to writing code in Swift, where you have nice typing for everything to help keep your data types straight. And I'm not going to go into detail on the second point, but if you ever mess with too many relationships in core data, there are some really weird methods where you can't just add a new element to this set. You have to get the immutable set value for a key and use that. It's a pain. But some of this sort of makes sense when you're writing Objective-C, and that's why it's still there. So let's get into how to make things a little better for Swift, because I use Swift for everything these days, and I use core data, and I've run into all these things firsthand, and I'm hoping I can help you benefit from my experience. That can be your sort of crash test dummy. So normally you would create a core data model with Xcode's model editor, which is a convenience, by the way. You can do all this in code, but most people use the model editor because it's a really nice way to set it up. And so for demonstration purposes, I've got this simple entity event, which has a few properties and relationships. You have simple stuff like a string and a date. Two relationships. One, the tickets relationship is a too many relationship because each event can have multiple tickets. The venue relationship is 2-1 because for this model, I'm assuming each event has just one venue. And you can have Xcode generate the classes that correspond to these entities. It'll do this automatically for you. In fact, by default, it does this for you. And it's got a couple options you can use here. You can have it generate a class definition, which gives you the full class with all the properties. Or you can have it generate just a category, which is Visual C Talk, or an extension for Swift, which is, will contain all of your properties and relationships, but then it's up to you to actually define the class that this corresponds to. So you get an extension on its own, not tied to anything. You create the class that it extends. And what this is going to give you then for the simple entity that I had on the previous slide is something like this, where you get properties for your various, you get attributes for your various entities and relationships there, plus a convenience relationship for creating fetch requests. You get this code for either of Xcode's generation options. If you choose the class definition option, it additionally generates just an empty class definition with nothing in it. And this is good enough for a lot of uses. Whether this is good enough depends on what your model looks like. The first thing that I don't like seeing here is that the tickets relationship is that generic NS set that I was talking about. And Xcode and core data just don't know how to do anything better with that. Often the best choice is to use the class definition option because then you just get a full solution for your class with everything. But that's also kind of a pain because you get a generated file for your class definition, which Xcode is going to overwrite anytime it feels like it. So you can't add in your own stored properties there if you need to add your own code to it. So you're a little bit limited in how you can extend it. And so yeah, I mentioned the extension. There's the NSSet to set conversion in Swift is a pain to do all the time. Scalar types can't be optional, which I really hate because sometimes a numeric type really needs to be optional, but Objective-C doesn't understand optional scalars. And since we're using core data, we're getting that limitation. You can't easily inspect the code either because since it's generated, Xcode puts it in the derived data folder. And so if you even want to see what code you have to like first write some code that mentions the class and then command click on it in Xcode to get it to show you what the source code is. But I'll talk about how to improve on this a little later on. So I mentioned optionals, which are the first two big WTFs. And if you look at core data in Swift, you may see, oh, Swift has optionals. Core data has optionals. Excellent, we're all set. Except, if you remember the timeline, core data is a lot older than Swift. And so its optionals were not based on Swift. In turn, Swift was not designed based on core data, so it has its own idea of optionals. So there's a conflict there in that they have two things which are both optional but in different senses. And so one of the most common things you see on Stack Overflow is something like this, where someone will say, oh, it's actually, I declared this property, this is required, so I set it to be non-optional. But then when I got this generated code, it's this optional thing. Why is that? And essentially, I assume most of you know more or less what Swift optionals are. They have to have a value anytime after you finish initializing your property. Core data doesn't care about that. It only checks when you are saving changes to core data. So it always generates properties as optionals. That's why. Getting around this is kind of difficult too, because as it relates to the second WTF, which has to do with what I was saying about not having optional scalars. So if you check the optional box for a numeric type like an integer, Xcode will generate something for you which is not optional, which is kind of a pain. And what's worst about this is that it's not just that it's going to be non-optional, it's that it's going to have a default value even if you don't assign one. Again, an Objective-C thing. If you declare an integer in Objective-C, don't assign a value, it defaults to a value of 0. Core data does the same thing. So what can we do about that? It would be nice if we could do something, if we could do some things that would make this a little bit easier to deal with in Swift. But to explain this, I'm going to get a little bit into the background of just a little bit of how core data works. And I mentioned using NSManageObject for everything. You start by creating entities in the model editor, and you typically want to create a subclass of that, but it's not actually required. And NSManageObject bare instances can just represent an entity, and the properties are then declared by the entity rather than by NSManageObject itself. And so where am I going with this? You've got this simple entity here. This is not actually a class declaration. It's not always obvious to everyone. This is just an entity declaration, and it's essentially the schema of your core data database. And it's possible, although not advisable, to do everything without even having a subclass. So you can say, I'm just going to create this instance of an NSManageObject representing the type named event, which is defined in my model. And then if I wanted to, for some reason, I can just use key value coding with that and use set value for key and just get value for key there to access it. It's not good Swift practice, but I mention this because it's important to have this understanding of what's going on behind the scenes in order to make things a little better in Swift. Now, I had these properties up before, and I brought this back because there's some details here you might not have noticed if you weren't paying attention. And the thing which seems weird about this if you're used to Swift is that this is an extension, but it's declaring what seem to be stored properties. How is that possible? And that's because of this mysterious thing, NSManage, at the beginning. Yeah. So this is where a lot of people will stop, reasonably so. But the thing is, NSManage isn't actually a stored property. It's sort of a promise to the compiler that this will exist at some point. It's kind of like a computed property, except that there's no get or set declared for it either. It's core data using some runtime magic to generate accessors on the fly at runtime. So NSManage says to the compiler, this doesn't actually exist yet, but I promise that it will when the code runs. And the compiler says, OK. And so it's not really a stored property. So yeah, it creates these accessors dynamically. And so this is really the key I'm leading up to, is that an NSManage declaration must match what you have in the entity. So if you have a string or an int in the entity declaration, then your NSManageObject property has got to match that. And that's kind of the way it usually seems. You seem like you're stuck there a lot of the time. But what you often don't realize, what a lot of people don't realize, is that NSManage is not required. You can, if you want, declare your core data class to have properties with names that match the entity, but types that don't actually match. They can be whatever you want them to be. And this is the key to making things easier in Swift in a lot of cases. So if I've got this property NSManage string, I could take that out and instead replace that with my own custom getter and setter, not NSManage, and do all the if you haven't used this kind of thing before, this is a standard core data dance with your custom accessors where you have to say things like, yes, I will change this value for the key. Yes, I did change this value for the key, so that core data can keep track of who's manipulating its data at what time in order to make sure that all the change propagations happen properly. Now, on the one hand, this looks like ugly boilerplate code, but it's the useful thing to have in your pocket because it means that you can use whatever types you want, and as long as you can map that to something core data understands under the hood, then you're good. So if you remember back to like 10 minutes ago, I said that core data properties must be representable in Objective-C, but that's just for the entity. That's not actually for your class. The class does that by default from Xcode, but you don't have to do that yourself if you don't want to. And so you can do something like, if I have this simple enumeration, I'd like to save this in my core data model as a property. And Xcode, by default, what I'd like to do, excuse me, is this have a property called event type, which is my enumeration. What Xcode is going to give me by default is instead this, which is an int16, which is a pain because it can take any valid integer value, not just things from my enumeration. So I can instead replace that with my own custom thing, get rid of the NSManage, declare my property of my enumeration type, and follow the same kind of pattern I did before, where I have the core data dance, but with the addition of converting between the entity raw value and core data's integer so that I can map one to the other. And so I get to use my Swift types here with core data, even though core data doesn't really understand them. This is a bunch of boilerplate code again. You can see it's stringly typed. And Xcode is not going to help you with this, unfortunately. In fact, Xcode will kind of make things difficult for you here if you let it generate code for you, because it will feel free to overwrite the generated files at any time. It's always going to generate code for all of its properties as NSManage. So it can get in your way when you try to do this. So you can turn off code generation. But then you have to write your classes by hand, maybe, except maybe you don't. Because there's this project some of you may have heard about called NoGenerator. And this slide is a little bit out of date because it mentions Objective-C. It does Swift now as well. And this is an open source tool that I work on that I contribute to, which is sort of an alternative to Xcode's code generation for core data. Hopefully doing a better job than what Xcode gives you. It's called NoGenerator because it's manage object generator. It generates your manage object subclasses. And it's been around for a while as well. It's also older than Swift. But unlike Xcode and the core data team, some of us who use and work on NoGenerator actually use Swift. And so we care about trying to make it better in Swift. And so that's where I come in. That's where this talk comes from. Doing this talk sort of motivated me to contribute some changes I've been developing on my own back to NoGenerator so that the community can benefit from them. And I'm hoping they'll help you out as well. So with NoGenerator, it's a command line tool. It'll read your data model and generate classes for you, hopefully doing a better job than Xcode. And because the Xcode model editor doesn't really understand Swift, a lot of this happens by way of, in the model editor, there's the section at the bottom called user info. You can add any arbitrary key value pairs you want to tell Xcode and core data about your entities and attributes. And you can put whatever you want there. So NoGenerator has a bunch of keys that you can use to tell it how the Swift code should be generated. And so one of the cool things one of the first things I like to get out of this is that I can have typed too many relationships. Instead of an NSSet, I can just have generated code, which is the proper type for a set of this relationship. And that on its own is just kind of an awesome thing for me because I hate having to convert back and forth. It's not hard code to write, but it's a pain to do it all the time. Optional scalars also just work. And although it is boilerplate code like I was talking about, it's boilerplate code that's just generated for you. So you don't have to worry about doing this yourself. It's just there with NoGenerator. So you can say, I've got this type of my, in this case, well, my optional scalar here. Core data doesn't understand that, but I do. And so I can do things like check for the value and set a nil for it. It happens. It's just kind of awesome that this works. And you may notice compared to the previous version of this type of code I had, there's no stringly typing here. There's no property name in quotes. Because one of the other nice things we do with NoGenerator is we just give you a structure that defines all of your property names for you. So that when you have this generated code that needs to use a property name you don't have to worry about getting the spelling right on it. It's there. This is also good for your predicates when you're fetching from core data, because you need to use the property name as a string there. You don't want to get the string name wrong, but you can use this to ensure that you didn't mistype it. In the simplest case, you just run this at the command line. You can build this in as an Xcode build phase if you want, which saves you a little bit of time going back and forth to terminal, so that you can have it automatically regenerate every time you change the model. And it generates 2 files for each entity. The ones on the top with the underscores contain all the boilerplate code that you shouldn't touch because it gets regenerated every time you run the program. The ones on the bottom are where you can put your own custom code, and those contain the class definitions. And these look something like this, where on the top, this is going to have a lot of stuff in it, the generated code, all the boilerplate stuff. The bottom one has almost the entire thing right here. It's just a class definition. You can put your own stuff. And so for the event example I've been using, this is literally the entire thing for the event.swift class. And this class only gets generated if it doesn't already exist, so you're free to put whatever code you want here. It's the class definitions, if it's stored properties, those can go there. So yeah, you're free to do whatever you want there, and NoGenerator will not interfere with that at all. The second file you get is a big one, potentially, even for small classes, and helpfully warns you at the top, this is generated code, you shouldn't edit it, because it may be overwritten, and that's fine. You can put your changes somewhere else. And so this allows you to do things like have properties which are Swift enumerations by using a user info key to tell NoGenerator what your enumeration type is. And so then if you have this simple enumerations of your event type, you can have a property which is actually of that event type instead of one that's an integer or something like that. This will work for any enumeration with a raw value that core data understands. So numeric properties and strings, for example. In principle, you can have raw values by extending raw representable protocol. Core data will not understand all of those, but if you can map it to something like a numeric, a string, a date, a binary blob, you're okay there. And I don't want to wield the massive wall of code here, but I just wanted to mention here that we're using kind of the same pattern for all of these. This is the way the enumeration works. We're using the raw values to go back and forth. And it just kind of works for you. So you also get support for codables, which is really nice. So any property, if raw valued enums aren't enough for you, you can have enumeration or a struct or whatever that conforms to Codable, and you can just get working support for Codable properties out of the box with NoGenerator, which is also really cool. I've used NS coding a lot with older Objective-C code, and I'm glad to have Codable working now so that I can just have that work as well with my Swift code and not have to worry about the Objective-C assumptions in NS coding. Internally, it's using JSON decoder and encoder. It could be any encoder, really. That's just sort of a convenient one. And I'm working, this is not in yet, but I'm working on doing this. I'd really like to have the option to have your managed objects themselves conform to Codable so that you could take incoming data, if it's JSON or whatever, and instantiate your model object directly from that. This isn't quite working yet because Codable and NS managed object have conflicting ideas about required initializers. You need to implement a custom initializer for Codable to work with this. And that's where the conflict comes in. But fortunately, Codable lets you pass in arbitrary user info objects, so you can do things like pass in your NS managed object context and then use that in your Codable initializer and get it to work right. There's still some thorny issues there, but it's something I really want to get in place. So it's one way or another it's going to be in there soon. And there are a few other options, but it's not a very complex tool. You essentially just tell NoGenerator where your model is, that you're using Swift, and where you want the files to go, the output dir. A couple other tweaks, like you can tell it to always import some other module in all of your core data classes if you want. It'll just insert it in them. You can separate out the the human editable files from the ones that get overwritten every time if you want. But there's not a lot to it as far as the command line. It's a pretty simple tool as those go. You can find this on GitHub, and all the stuff I've been talking about is on the Swift 4.2 branch, which I've been developing over the past few weeks, which I really hope to merge into master soon, because I want this to be in there for everyone to use. But if you're feeling daring and want to try it out, check out the Swift 4.2 branch. So anyway, thanks.